Welcome to this channel, and in this video we're going to be looking at monotonicity of functions. And this is basically the property of a function to increase or it decrease across a particular interval, or possibly across the entire function. Maybe it's totally increasing or totally decreasing, or maybe for some interval the function is increasing, or for some interval the function is decreasing. So how does this apply to differentiation? So if I should visualize this on a graph quickly, this is a graph of y equal to x squared negative 4x plus 3, and then in previous videos we discussed how to determine minimum and maximum points, and via calculation you discover that in order to determine the minimum points you're going to get 2 comma negative 1, right? And then one interesting fact here is that starting from left to right, that's from left to right in this curve, look carefully at the y values. You see that they are doing what? They are decreasing. And at this point you can see that the slope is negative. If you find the change in y over the change in x, is going to be negative because the y values are what? Negative, x values positive, negative slope values. But once it gets above the slope, that is when the slope is greater than 0, the function increases. So basically the point here is, if you have a function and you're asked in the exam, right, to determine the set of values for which the function increases or for which is a decreasing function or an increasing function, if the first derivative of x is greater than 0, that means that gives you the set of values for which the function is doing what? Increasing, right? And then for the first derivative of x less than 0, that gives you the set of values for which the function is decreasing. Are you following? Alright, so let's take questions. So let's take this first question. First question, if you're given f of x equals x cubed x squared negative 3x, and you're asked to determine the set of values for which it increases and then I decreases. Don't waste time. You should be able to get the first derivative. If you don't know how to do that perfectly, do well to watch my video on derivatives part 1. Alright, so if we should differentiate this, 2 comes down, right? It becomes 2x to the power 2 minus 1, which is 2x, and then negative 3x. If we differentiate negative 3x, you're going to get negative 3, right? So 2x negative 3, for a function to increase across a certain interval, this should actually be greater than 0. So negative 3 crosses over, that means that 2x is greater than 3, and then dividing 3 by 2, what are you going to get? Dividing 3 by 2, you have that x is greater than 3 over 2, or you could say x is greater than 1.5. And it's important to note that if you should want to represent this in interval notation, you can have a number line. Are you following me? Let's say here is 0, here is positive infinity, here is negative infinity, and here is 1.5, which is 3 over 2. So we are looking at values greater than what? 3 over 2. So basically we could represent it as 3 over 2 down to what? Infinity. Are you following? Increasing. And you can see that I used parentheses because 3 over 2 is not inclusive, because if you substitute 3 over 2 in the inequality, you're going to get 0, right? But we're looking at values greater than 3 over 2. Then in the case of decrease, all you simply need to do, that the first derivative should be what? Less than 0. So this crosses 2x less than 3, dividing 3 by 2, you have x less than 3 over 2, which if you should visualize on a number line, this is negative infinity, this is 3 over 2. You are looking at values less than what? 3 over 2. So from negative infinity down to what? 3 over 2. That is if you want it in the interval notation, which they could actually it could actually be a form of putting the options in the exam, right? So if we should visualize it so that I have a clearer understanding, the graph of x squared negative 3x looks like this, right? And you can see that the minimum point of the curve is what? What's the minimum point? Remember that we got 1.5, right? We got 1.5. So this is the minimum point at x equals 1.5. So when x is now greater than 1.5, you can see that the function is what? Decreasing. Then moving from the left, you can see that it's decreasing. Do you understand? So let's take more questions. So question number 2. If you are given this x cubed over 3 negative x squared negative over 2 negative 2x, and you are asked specifically in the exam to determine the set of values of x for which this function decreases, what are you going to do? Differentiate the function, right? So the first derivative of the function, what happens? 3 comes down, right? So it will be 3x to the power 3 minus 1 over 3 negative 2x to the power 2 minus 1 over 2 negative 2, and then this cancels out. You're going to be left with x squared negative x negative 2. So what's the next step? If there should be a decrease, what happens? That means that the first derivative of x should be less than 0. So all you simply need to do is what? X squared minus x minus 2 less than 0. You need to solve this inequality, this quadratic inequality. So you can actually do some factorization here. The coefficient of x squared is 1. 1 times negative 2 is what? Negative 2. So all you need to do is to look for two numbers you're going to multiply that are going to give you negative 2. You're going to add that's going to give you what? Negative x. And that's simply 1 and negative 2. Right? So x squared plus x negative 2x negative 2 is less than 0. So that will be x is a common factor. So x into x plus 1 negative 2 into x plus 1 will be less than 0. That's the factorization. And then bringing this and this together, we have x negative 2 into x plus 1 less than 0. And then what next? The next step here is to equate it to 0. That's actually a method I actually use to get it. Equate each component to 0 so that we can get those important points that we need. So if we equate x minus 2 to 0 and x plus 1 to 0, we have that x is 2 and x is negative 1. Do you agree? This is not the answer. You sketch a number line as fast as you can, and then let's here be 0, let's here be negative 1, and let's here be 2. You just visualize it, right? Here is positive infinity, here is negative infinity. So these are the two important points. I know that for these two values, this inequality will be equal to 0, but we are just using that as an advantage. So if we test for any value in between these two values, in between negative 1 and 2, for example 0 is in between, right? If you substitute 0 in this inequality, x negative 2 into x plus 1 less than 0, what are you going to get? 0 minus 2 into 0 plus 1, right? Now we are now going to test, is it going to be less than 0? That's it. So 0 minus 2 is what? Minus 2. 0 plus 1 is what? 1. Minus 2 times 1 is minus 2, which is less than 0. So this region is approved. Now if you test any value less than minus 1, for example minus 2, if you substitute minus 2 in this inequality, to be what? Minus 2 into minus 2 plus 1. Minus 2 is what? Minus 4. And minus 2 plus 1 is what? Minus 1. So when two negative numbers multiply, you're going to have a positive output which is greater than 0. But by looking at values what? Less than 0. So this region is wrong. And if you test any value greater than 2, for example 3 or 4 or 5, any number down to positive infinity. For example, if you use 5, 5 minus 2 is what? 3. 5 plus 1 is what? 6. 6 times 3 is 18. And 18 is positive. We are looking at negative values. So this region is also wrong. So basically, the set of values for which the function decreases is simply the fact that x should be what? Greater than negative 1, x less than 2, which we could now put together as negative 1. If x is greater than negative 1, that means that negative 1 is less than x. And since x is less than 2, we can combine it. This is what is happening over here, right? From negative 1 to 2 is okay, right? Excluding negative 1 and 2, because you can see we are using greater than minus 1. So if we now want it in interval notation, we can simply say from negative 1 to what? To 2. Agreed? So that is the solution to the question. So let's take this question now, and then if we should visualize it, let's so that you have a clearer understanding of this. We should visualize it x cubed over 3. X cubed over 3 is coming up. This is not the graph. X cubed over 3 negative x squared over 2, right? And then negative 2x. This is the graph of the curve. Can you see it? Okay, so the question said set of values for which is decreasing. So from left to right, you can see that is across this region that there is a decrease. Are you following? There's a decrease here. And then where did that start from? Remember that we got our answer as what? Values from negative 1 to 2. So you can see that negative 1 is actually the maximum point, the value of x for which the function attains the maximum, right? Negative 1. But after that negative 1, there is now a decrease. You see that there is now a decrease in the x, in the y values. You can see that the y values are decreasing, and then down till where it will now get to 2. Remember we said from negative 1 to 2. Are you following? It now stopped at 2. The decrease now stopped at 2. You now see that from this point now, the increase will start, and we are not concerned about the increase in this case. Are you following? So that is the solution to the question. Now, with what I've taught, you should be able to answer this question on inequalities, and then we wrap up this video. Alright, so when I write down the question, please pause the video attempt following the same principles. They are given the curve x cubed negative 5 over 2x squared negative 2x plus 1, and you're asked to determine the set of values for which the curve is increasing. Pause the video please and attempt it so that you can master it, right? So if you get the first derivative of x cubed, 3 comes down, right? So it will be what? 3x squared, 3x to the power 3 minus 1, and then negative 5 over 2 times 2x to the power 2 minus 1. I'm differentiating. Then if you differentiate negative 2x, you're going to get negative 2, and differential of a constant is what? 0. Very good. So this cancels this. This will be 3x squared negative 5x negative 2. And what's the condition for a function to increase? What happens is the fact that the first derivative of x should be what? Greater than 0. So all we simply need to do is to solve the inequality 3x squared negative 5x negative 2 greater than 0. Right? So what do you simply do? These are the two end values, 3 and negative 2. Look for two numbers. You are going to multiply that, give you negative 6, because 3 times negative 2 is negative 6, and I'm going to add, that's going to give you negative 5. And that's simply what? Negative 6 and 1. Right? Because negative 6 plus 1 is negative 5, and negative 6 times 1 is negative 6. So 3x squared negative 6x plus x negative 2 should be greater than 0. So factoring out 3x into x negative 2 plus 1 into x negative 2 should be greater than 0. And then bringing these two together, what I'm going to have 3x plus 1 into x minus 2 should be greater than 0. Right, so following the steps I gave, draw a number line. First of all, you have to equate the components to 0. If you equate 3x plus 1 to 0, what are you going to get? The positive 1 shifts over, it becomes 3x equal to negative 1, and then dividing through by 3, you have negative 1 over 3. And then x negative 2, if you equate to 0, is going to give you 2. So these are your two important points. So if this is positive infinity, negative infinity, and then here is 0, here is 2, and here is negative 1 over 3. Simply test within these 3 points. Values less than negative 1 over 3, values in between negative 1 over 3 and 2, and values greater. Once you do that, the job is done. So if we test for values in between negative 1 and 1 over 3 and 2, for example, 0 is in between, right? Very good. So if you substitute 0 in this inequality, 3x plus 1 into x minus 2 greater than 0, you substitute 0, what's it going to be? 1 into 1 minus 2. And then we now test. 1 minus 2 is what? Minus 1. And minus 1 is not greater than 0, right? Is it? It's not. So this region is totally wrong. No matter the value you use, it's not compulsory to use 0. You can use 1. If you substitute 1, what do you get? 3 times 1 is 3 plus 1, 4. And then 1 minus 2 is negative, right? So every stuff inside there is going to give you a negative value, which that's not what we're looking for. And then if you test for any value less than negative 1 over 3, for example, minus 1. If you substitute minus 1 in this inequality, what will you get? That will be 3 into minus 1 plus 1 into minus 1 minus 2, right? So that will be negative 3 plus 1 into what? Negative 3. Because negative 1, negative 2 is negative 3. And negative 3 plus 1 is negative 2, right? So negative 2 times negative 3 is positive 6. Are you following? Positive 6. and you can see that this is allowed. This is a positive number, is greater than 0, right? And then if we test for any value greater than 2, are you following? Greater than 2, for example 3 or 4. 3 into 3 plus 1 plus into 3 minus 2 is going to give us what? 3 times 3 is 9. 9 plus 1 is what? 10. 10 into 1, which is 10, which is greater than 0. So this region, no matter the value you enter here, will be correct. So basically our final answer in interval notation could be negative infinity to negative 1 over 3. And then since these values are excluded, we now use the union 2 to what? Infinity, right? Or if it's an inequality form, we are looking at values less than negative 1 over 3, right? This is what we are saying here. Values less than negative 1 over 3 and values greater than what? 2. They'd have no meeting point. So x less than minus 1 over 3 and x greater than 2. This is another way of putting the answer. And these are the sets of values for which the function increases. Now let me visualize, and then this video is over, right? So the graph of the function is given as x cubed. It's coming right up, so this is not it. So this is x cubed negative 5 over 2x squared, 5 over 2x squared, and then plus negative 2x, sorry, and then plus 1, plus 1. And now this is it. This is the graph of the function, right? Okay, so what do you notice here? Remember that the values we got, what did we get? We had x should be less than negative 1 over 3 and x should be greater than 2. And looking at this, what do you have here? Is it not 2? So you can see that from 2, from negative, what's over here? Negative 0.33. I don't know if you can see. Negative 0.33, which is the negative 1 over 3 we got, right? Are you following? Negative 1 over 3. So at this point, you can see that the function is doing what? What was the question? What was the question? So that you understand what it's saying. The question said set of values for which, sorry, it's increasing. And the first inequality says that x should be greater than 2. And from this graph, you can see that when x is greater than 2, what is happening? There's an increase. And when x is less than negative 1 over 3, there is also an increase, because remember we are looking at it from left to right. So when you are going this way, there's an increase, right? There's an increase across this, there's an increase until you now get here, and then there's a decrease, and then there's another increase, right? Thank you so much for watching this video, and I believe you learned a lot from this, and I believe also that any question that comes up on determining the set of values for which a function is increasing or decreasing, you should be able to ace it for the Maths 103 exam. Please, if you've not subscribed to this channel, please do well to subscribe. Click the subscribe button, like this video, share this video to others who need them. Thank you so much once again, and have a nice day.